Good morning, good afternoon, or good evening. My name is Anthony, and on behalf of my co-authors, Khalid, Christian, Mohamed, Ali, and Fabio, I will be presenting details of our tool, tsDetect, an open source test smells detection tool. First, let me provide a brief introduction to test smells. Test files, like production files, are also subject to smells, or, in other words, bad programming practices, such as violations in X-Unit guidelines and concepts. Test smells were first introduced in 2001, and throughout the years, researchers have been adding additional smell types to the test smell catalog. Researchers have also studied the evolution of smells and looked at ways to eliminate smells from test files. There has also been work on tools to detect test smells. And finally, most of the studies on test smells have been on traditional Java systems. As mentioned, prior work on test smells include the creation of detection tools. However, most of these tools are limited in the number of smell types that they can detect. Hence, a single tool that can detect a variety of test smells will help with developer productivity. Hence, the goal of our work is to provide the community with a single tool to detect multiple types of test smells. Furthermore, by releasing this tool as open source, developers can extend the tool to support additional smell types in the future. tsDetect is an open source test smells detection tool. As a command line tool, tsDetect can run as a standalone executable to analyze JUnit-based test files for the existence of test smells. The tool does not require human intervention once it begins execution, and hence, it can be integrated into an automated build process. The code is available on GitHub and has already been forked a number of times. Shown here is a high-level overview of the architecture of tsDetect. As input, tsDetect requires the path to all unit test files and production files. tsDetect utilizes Java parser to build an AST for each file under analysis. We designed tsDetect in such a way to easily facilitate the addition of new smell types. Each smell is implemented and runs independently of other smells, and the detection strategy of each smell type is self-contained within its own module. On completion, the results are saved into a CSV file, which can be imported into a database system for further analysis. At present, tsDetect can detect 19 different smell types. Shown here are the 19 smell types. These smell types have been defined and utilized in prior peer-reviewed published literature. Please refer our paper or website for details around the detection logic for each smell type. For example, a test method containing more than one assertion statement without an explanation message results in the assertion roulette smell, while a test method that does not contain a single assertion statement or a test annotation parameter results in an unknown test smell. To evaluate the performance of tsDetect, we provided 39 students with smelly unit test files. The students were required to identify the type of smells or smell that was exhibited from the files. Details about the annotation process are provided in the paper. We captured the performance for each smell type. As can be seen from the table, the average F-score value was 96.5%. Developers can integrate tsDetect into their development toolset and workflow, such as the build process. Furthermore, a survey of developers confirmed the findings of our tool. tsDetect has also been utilized in quite a few research studies around test smells, including integrating tsDetect with other systems, maintainability, evolution, and refactoring studies. Please visit our website for an updated list of research publications that utilize tsDetect. Finally, educators can use tsDetect in a classroom environment to teach students about the importance of designing high-quality and maintenance-friendly test suites. For more details about our tool and research into test smells, please visit our website testsmells.github.io. Thank you.